Hello everyone, today I will walk you through my security assessment of the Soft application. I choose this one because it sets the gold standard for security research, intentionally designed with a wide range of vulnerability mapped to the OWASP top 10. To ensure a comprehensive assessment, we use three software solutions. Simpref provides an inside-out view to identify code-level logic errors, and WhatsApp conducted outside-in dynamic analysis to uncover runtime and configuration risk. And last one, the dependency check performs software composition analysis by checking project dependencies against the NVD to detect supply chains vulnerability, and our methodologies were systematic, organized into four key phases. Phase one, we established an isolated Docker sandbox for safe and replicable testing. Next, we documented tool installation and conducted targeted scans across source code, runtime, and dependency layer. Next, validation, we manually validated finding per tools to distinguish between true and false positive. And last one, we perform gap analysis to evaluate tool limitations and conclude our comparative evaluation. About key takeaway, applying secure software development life cycle theory to real-world projects was challenging. Setting up network proxy proved that security tools are not plug and play and require careful configuration. I learned that automated tools are powerful but imperfect, requiring human expertise and verification. Ultimately, now I know security as a continuous process of code review, monitoring, and proactive dependency management. In summary, this project has basically changed how I view developers' responsibility in building and maintaining secure application architecture. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. Doctor, my name is Ayub Hussein Ahmed, and I will present my part of this project. I was responsible for the SimGraph static application security testing, or SAST, and the also exam dynamic application security testing, also known as TAST. First, I will explain the SimGraph test execution. SimGraph static application security testing tool is it analyzes the application source code without running the application. The purpose is to identify insecure coding practice and potential security vulnerabilities at an early stage. So for this project, we run SimGraph on the OSP choose source code using PowerShell. After the scan was completed, SimGraph generated a report containing all the detected security findings. So in part C, after the scan was completed, the SimGraph detected a total of 41 security findings in the OSF choose shop application. These findings include different types of vulnerabilities such as SQL injection, command injection, cross-site scripting, traversal, hard-coded secrets, and open redirect. Most of these findings were classified as high risk because they could affect the security of the application if they are not fixed. This table shows some explanation of the vulnerabilities created by SimGraph. The first finding was running shell injection, which may allow attackers to execute malicious commands. The second finding was SQL injection, where users' input may be used to manipulate database queries. Another finding was path traversal, which could allow attackers to access files outside the attempt directory. These examples show that SimGraph can detect different types of coding-related security issues. After receiving the scan result, we did not accept everything found immediately. We manually reviewed several files to determine whether they were true positive or false positive. Most of the findings were confirmed as a true positive because the vulnerabilities actually exist in the source code. However, one finding related to GET tokens was considered a false positive because it appeared only in testing of educational code and did not represent a real security issue. So next we map the detect vulnerabilities to our set top security risks, for example, SQL injection, command injection, and cross-site script belong to OS A03, which is injection. Hardcode secrets relate to A02, cryptographic failures. Path traverse and open redirect are related to open access control. This mapping helps us understand which major security risks affect the application. First, negative analysis. Although SimGraph predict many vulnerability, it has also has some limitations because it's a static analysis tool. It only analyzes the source code and does not execute the application. Therefore, it may not predict business logic, vulnerabilities, or authentication bypass issue. It also cannot identify runtime configuration problems such as missing HTTP, security headers, or insecure several settings. These type of vulnerabilities are usually the dynamic applications. So next, I will explain the OSAP testing process. OSAP is the dynamic application security testing tool. Unlike SimCrab Zap test the application while it is running, we configure the target URL, the local host 3000, and selected the default dev standard scan policy. Zap automatically created the application, analyzed the web page, and tested the application for common security vulnerabilities. As you can see here. This is the image. So the part D, after the scan was complete, our ZAP identified several security issues. The scan detected 2 million risk findings, one low risk finding, and one information finding. The main findings include a missing contact security policy header, cross domain misconfiguration, and timestamp disclosure. As you can see here also. So this table summarizes the findings predicted by OCM SAM. Also this one. So the fast negative finally also has some limitations. It cannot detect business logic vulnerabilities because it only tests the application from the outside, and it also cannot analyze the application source code. Therefore, vulnerabilities such as insecure coding practice or hard-coded credentials are better detected by SendGraph. This demonstrates that using both SAST and DAST together provides a more complete security assessment. So that's all for my part. I'll pass to the next person.
Hello everyone, my name is Rabia Farzana Shikdar. My number is MEC251043. So today I'm going to present our secure software engineering structure comparative analysis of security testing tools where we evaluate SameGraph, WhatsApp JAP, and website dependency check on the intentionally vulnerable juice shop application. Looking at our comparative detection matrix, SameGraph scan over 1000 files and detect 41 findings. WhatsApp JAP log 4 dynamic alert categories and dependency check isolated 37 library vulnerabilities across 20 packages, while dynamic findings had exceptional high validation trust. Static result generated false positive flags on mock challenge test parameters. Our matrix illustrated the tools cover highly complementary. SameGraph is excellent for detecting A03 injection vectors in developer files. WhatsApp Jab excels at uncovering A05 deployment and security header misconfiguration. Finally, dependency check serves as our dedicated safeguard against A06, identifying library level risks that static and dynamic test completely ignore. Regarding user experience, SameGraph was highly accessible, passing our repository in seconds. Dependency check was straightforward but faced rate limited hurdles. Monitoring NVD database, WhatsApp just was the most labor intensive, requiring container port setup, local proxy configs, as long scanning runtimes. Now, my individual reflection from this project was focusing on software composition analysis completely shifted my perspective on modern application security. The initial setup with Docker presented immediate real-world engineering challenges. I quickly realized the scanner could not map dependency accurately with a clean manifest which forced me to spin up a standalone container just to generate a proper packages. Furthermore, navigating NVD rate limited restriction required a strict command line using arguments. Ultimately, while my team focused on securing one custom code as by SAST and DAST, this exercise taught me a stark lesson. An application primary most violent attack surface often hides silently with this third-party supply chain. So this was from my end. Thank you.
Hello everyone, I am Shang Zhen. My part is OWASP, dependency check. It is an assay tool used to check vulnerable third-party packages in OWASP Juice Shop. First, I prepared the Juice Shop dependency files. Then I generated the package.json file because the first scan result was not useful. After that, I ran dependency check with Docker and exported the HTML report. Luckily, the file scan was successful. Dependency check scanned 20 dependencies. It found 20 vulnerable dependencies and 37 vulnerabilities. This shows that old packages can bring many security risks. I selected the 5 main findings. They are JSON Web Token, Crypto.js, Notion, MassDB, and static HTML. Some of them are critical vulnerabilities, such as JWT bypass, weak cryptography, prototype pollution, and command injection. Manually check the package name, version, file path, and vulnerability description. The 5 selected findings are true positives. Most findings are mapped to OWASP A06, vulnerable and outdated components. To be honest, this part was harder than I expected. I spent almost a whole night fixing errors and waiting for the scan. But I learned that security testing is not only running at all. The environment, the dependency files, and the model checking is also important. That is all for my part. Thank you.